Every company has a secret it'd rather forget. For Yamaha, the mistake lived in a line of code. In 2022, dealers quietly received a message marked O2022-002R. The bulletin described a software glitch that could make an engine spark even when the key is turned off. This happened. It's documented. And it forced Yamaha to admit that in the modern age, even a perfect engine can fail because of a single misplaced instruction. Let's uncover the mistake Yamaha hoped you'd never notice. So, what exactly went wrong? To understand what really happened, you have to picture Yamaha's pride, the VF series, part of the brand's high-performance 4-stroke family. Engines like the VF200, VF225, and VF250. Sleek, powerful, and built for serious speed. Owners loved them for their torque, their whisper-smooth idle, and their reliability. But in early 2022, something unsettling surfaced. Dealers began reporting strange electrical readings during maintenance. Engines would occasionally spark even with the ignition key turned off, a behavior that shouldn't happen under any circumstances. Yamaha's engineers dug deep into the ECM, the engine control module, the small box that functions as the motor's digital brain. What they discovered was unnerving. A logic fault in the ECM code. Under rare conditions, especially when operating the trim or tilt switch while the key switch was off, the ECM could mistakenly energize the ignition coils. That meant electricity could arc where no ignition should occur. And if fuel vapors were hanging around the engine compartment, that spark could theoretically ignite them. A tiny bug, just a few lines of code written years earlier, but inside an outboard engine, tiny can mean catastrophic. Yamaha launched the factory modification campaign O2022-002R. The affected models were the VF200LB, VF200XB, VF225LB, VF250LB, and VF250XB. All were built between 2021 and 2022. These were serious motors, 200 to 250 horsepower beasts designed for offshore fishing boats, high-performance center consoles, and commercial applications where reliability is mandatory and not just preferred. Owners were told to stop using affected engines until dealers could reprogram the ECM, no parts needed replacing. No mechanical teardown required. Just a careful rewrite of the software that controlled ignition timing and coil activation. Each reprogrammed motor got a discrete label near the serial plate, proof of correction. No injuries were reported. No explosions made the news. The system worked, a silent fix before a loud disaster. Still, beneath that calm surface, one truth lingered. This was not their first close call. Years before computers ruled the engine room, Yamaha's lessons came from metal and fuel, not microchips. In the early 2000s, Yamaha's HPDI, high-pressure direct injection two-strokes, were the talk of every marina. The idea is a bold one. Combine a two-stroke punch with cleaner emissions and better fuel efficiency. The technology used high-pressure direct injection to inject fuel and oil separately directly into the combustion chamber. More precise fuel delivery, less waste, cleaner combustion. On paper, it looked like the future. But reality hit hard. The HPDI engines were notoriously sensitive to fuel quality. Injectors clogged, oil pumps seized, power heads failed without warning. Mechanics grew wary of them, and forums filled with owners comparing repair horror stories. The high-pressure oil pumps proved prone to failure. The injectors would clog. The system demanded meticulous maintenance that most recreational boaters simply didn't perform. Yamaha issued service bulletins and updated components, but the damage was done. By the late 2000s, HPDI quietly faded from the lineup. The technology expected to save the two-stroke engine became instead the reason Yamaha abandoned them and committed fully to four-stroke development. Then came the fuel connector O-ring recalls, this time affecting four-stroke models between 2015 and 2018. A small rubber seal inside the fuel hose connector could crack or degrade, allowing fuel to leak. The affected models included certain F150 through F300 four-strokes and several portable engines. The problem was straightforward. O-rings that should have been reliable weren't. The fix, equally straightforward. Dealers replaced fuel hose assemblies and connectors. Parts that should have been reliable weren't, so you swap them for parts that are. A mechanical problem? Simple, visible, and fixable. Dealers swapped out connectors and moved on. Around the same era, owners of smaller F40 and F60 models complained of vapor lock, a heat-related fuel pump issue that caused hard starts in warm weather. These weren't official recalls, but they were widely discussed among owners and mechanics. Boats would run fine in the morning, then struggle, or stall completely in the afternoon heat. The fuel pumps couldn't handle sustained high temperatures. Fuel would vaporize in the lines before reaching the engine. Not a formal recall, but Yamaha updated parts mid-production to quietly solve it. Fixes included retrofitted fuel pumps with better heat tolerance and updated fuel lines with improved insulation. Yamaha dealers were well aware of the problem and had unofficial solutions. One by one, these experiences taught Yamaha a fundamental truth. Every system, no matter how refined, eventually reveals its weakest link. Back then, those weak links were physical: rubber, metal, and fuel. By 2022, that reality had gone digital. Inside Yamaha's engineering offices in Iwata, Japan, the discovery of the ECM issue triggered swift coordination between Japan, Europe, and North America. Outboards operate in some of the most volatile environments on Earth: saltwater, heat, vibration, and unpredictable voltage loads. Even a brief electrical surge during tilt or trim operations could create ghost signals inside an ECM. That's exactly what the engineers traced: a control logic pathway that failed to block coil energization when the key circuit was off, a few electrons wandering down the wrong corridor. Under certain conditions, turning off the key switch or activating the trim and tilt function could trigger a state where the ECM still sends power to the coils. The problem was not in the hardware. The coils themselves were fine, the wiring, fine. But there exists a problem in the code, in the decision tree the computer followed to determine when coils should fire and when they shouldn't. The recall campaign was structured with precision. Dealers received diagnostic software, a step-by-step ECM reprogramming protocol, and stickers to mark completed units. Affected serial numbers included models across the VF200, VF225, and VF250 lines, both standard and X-long shaft versions. In internal memos, Yamaha's tone was matter-of-fact, not alarmist, but firm. The message: do not operate these engines until the ECM modification is completed. That's how you know the company took it seriously. To the public, it looked like routine maintenance. But for those who understand marine engineering, it was a landmark moment. One of the first times a major manufacturer had to correct a software behavior that could cause physical ignition risk. The recall marked the new frontier of mechanical reliability. When logic fails, mechanics can't see it. The strange beauty of this story is that Yamaha's failure was also proof of its evolution. Old engines failed because gaskets split or bolts snapped. You could see, smell, and touch the problem. Now, the same danger hides in invisible sequences of binary logic. A single misplaced instruction, one where there should be a zero, can tell an ignition coil to fire when it shouldn't, or a sensor to report false data. And unlike hardware wear, software doesn't degrade gradually. It either works perfectly or not. That's why recalls like the 2022 Yamaha Bulletin feel eerie to old-school mechanics. They can rebuild a carburetor blindfolded, but they can't debug code. Yet the fundamentals remain the same: precision, patience, and humility before complexity. When Yamaha engineers traced the fault and issued the correction, they demonstrated that lesson in real time. The problem exists deep inside a program and not hidden under a cowling. And they fixed it before it hurt anyone. And that evolution comes with new responsibilities. Today's marine engines, whether Yamaha, Mercury, Suzuki, or Honda, are marvels of mechatronics. They combine fuel injection, real-time monitoring, variable cam timing, and GPS-linked diagnostics. But every layer of sophistication adds new points of failure. The 2022 Yamaha recall stands as a small but crucial reminder. Even the best systems can make logical mistakes that no human hand could predict. For boaters, awareness matters more than distrust. Every software update, every service bulletin is part of the quiet dance between progress and precaution. The more complex we make our machines, the more attention they demand in return. This makes modern engines simultaneously more capable and more mysterious. They run cleaner, more efficiently, with better performance than purely mechanical engines ever could. But when they fail in ways that are harder to diagnose, harder to understand, and sometimes harder to fix. The 2022 ECM recall required Yamaha to develop new software, test it, distribute it to dealers, and reprogram thousands of engines one by one. So, what does this mean for Yamaha owners? If you own a Yamaha Outboard, especially one built in the last decade, here's what you need to know. First, check if your engine has any open recalls or modification campaigns. Yamaha maintains a service campaign portal where you can enter your engine serial number and see if there are any outstanding issues. The serial number is stamped on a plate attached to the mounting bracket. Write it down and check it against Yamaha's database at least once a year. You must understand that modern outboards are fundamentally different machines from those they were 20 years ago. They have computers, sensors, and software. That means they need different kinds of maintenance. Software updates are essential. When Yamaha issues a modification campaign like the 2022 ECM reprogram, get it done. Don't wait. Don't assume your engine is not affected. The risk might be small, but the consequences of ignition in the presence of fuel vapors are severe. Keep your dealer relationship current. Independent mechanics might be great at fixing mechanical problems, but software issues often require factory diagnostic tools and access to proprietary repair procedures. If you're running a modern 4-stroke with electronic fuel injection and computer control, having a dealer who knows your engine and can access Yamaha's technical support network is invaluable. Recognize that recalls and modification campaigns aren't signs that you bought a bad engine. They are signs that the manufacturer is monitoring performance, tracking issues, and taking responsibility when problems emerge. Every major outboard manufacturer has recalls. Honda, Mercury, Suzuki, all of them. Part of how modern engineering works. You build something complex, release it into the real world, and discover edge cases and failure modes that didn't show up in testing. The real takeaway is awareness. Yamaha fixed their mistake quickly and responsibly. But the story lingers because it represents a threshold moment, the exact point where marine engineering stopped being purely mechanical and stepped fully into the digital realm. A realm where torque meets code, and where the smallest error can ripple across thousands of engines worldwide. So next time you turn the key and hear that Yamaha roar to life, remember this: what keeps you moving goes beyond the pistons, the propeller, or the roar of the exhaust. There's also the invisible logic pulsing behind the scenes, a web of instructions as delicate as it is powerful. And somewhere, deep inside that code, lies the lesson Yamaha had to learn the hard way. Perfection in engineering is never permanent, just the pause between one fix and the next. And that brings us back to Yamaha's quiet mistake. The 2022 ECM recall is the kind of mistake Yamaha probably wishes everyone would forget. It affected premium motors. It involved a software flaw in sophisticated systems. It created a genuine safety risk. And it happened despite extensive engineering and testing by one of the most respected names in marine propulsion. But forgetting it would be a mistake for all of us. This recall, and the pattern of mistakes that preceded it, tells us something important about where marine engine technology is heading. We're moving from an era where engines failed mechanically to an era where they fail electronically. From problems you could see and fix with tools to problems that exist only in code and require computers to diagnose and repair. That shift changes what it means to own and maintain an outboard. It changes what skills and knowledge matter. It changes the relationship between owner, dealer, and manufacturer. Conclusion: understanding these mistakes doesn't mean avoiding Yamaha motors. It means understanding what you're buying when you buy a modern 4-stroke outboard. Your resin, buying sophistication and capability, but you're also buying complexity and the new kinds of problems that come with it. Have you been affected by any of these Yamaha recalls? Did you experience HPDI problems or fuel connector issues? Share your story in the comments. Understanding how these problems played out in real boats helps all of us make better decisions. Thanks for watching.